Now, let's turn our attention to a topic where innovation means impact in the most personal way: healthcare. Technology has given clinical tools to detect diseases faster, make smarter decisions, and deliver care that truly fits each patient's needs. But as the machine gets smarter, how do we ensure that human touch remains at the heart of care? How do we make AI a partner rather than a replacement in life changing decisions? In this section, the algorithm will see you now, Kevin Carlson, partner and AI practice lead at TechCXO, will explain how AI is reshaping healthcare, revealing both its incredible potential and the challenges of keeping patient care human centered. Please join me in welcoming Kevin Carlson to the stage, and let's give him a round warm of applause.
Takes a while. All right, just want to tell you a little bit of story about guardrails here. In May of 2022, a 91-year-old man named Gene Lockard fell on his home. He broke his leg, he broke his ankle. He was admitted to the hospital and then to a rehab facility for physical therapy. His therapist described his condition as immobile and weak. All right, so Gene broke his ankle and his leg. And less than 3 weeks later, his insurance company told him to go home. It's not his doctor, not his physical therapist, the insurance company. This is a real documented case, by the way. I'm just not using the names because I don't want it to detract from the real topic here, which is guardrails. The health insurance company had deployed an algorithm, an AI algorithm that was built by one of their subsidiaries. It compared Gene's condition to about 1,000 other similar patients and gave a prediction that Gene had had enough care, cut him off. The treatment facility disagreed, his physician disagreed, therapist disagreed, but the algorithm's output triggered a coverage denial. So he was forced to either move out or pay. So he ended up paying $14,000 a month. It's pretty steep, but they chose to keep him in care for a year. Gene died in July of 2023 at the treatment facility. But this isn't an isolated case. There was a 74-year-old stroke victim that was denied post-acute care repeatedly from the same algorithm. The doctors insisted that the patient needed treatment, but it wasn't provided by the insurance companies. Another family caught in the same loop. Every time they won an appeal, there was a new denial immediately. This became a class action lawsuit and reached federal court. And the judge himself said about the insurance company's appeals process, he called it futile. This is a number you should remember. 90% of the appeals that were made because of the decisions of this model were overturned. 90%, 9 out of 10. Who would deploy a model with a 10%, accuracy rate these days? Unfortunately, the company knew it, but they kept using the model. The other thing that was in their favor was that 0.2% of policyholders ever make an appeal. So the math worked in the favor of the insurance company, not in the favor of those that were insured. This isn't a story about AI gone wrong. I'm a huge fan of AI. I lead the AI practice at TechCXO, our partnership, and do a lot of great stuff with it. This is a story about what goes wrong when it's not deployed correctly, when there's no guardrails. So this is a signal, right? This is a signal that says something's got to change. AI is here to stay. We hear it all the time. We know these models are out there. We know they're in use. Yes, they're getting better, but they're not good enough. So let me show you what the right signal looks like. ECRI is an independent patient safety organization, and they named the misuse of AI chatbots as the #1 health technology hazard for 2026. Not number 5, not an honorable mention, the number one risk. Their researchers documented chatbots that suggested incorrect diagnoses, recommended unnecessary testing, and in one case, invented body parts in response to medical questions. In another test, a chatbot told clinicians they could hook up an electrode to a patient's shoulder blade, which would have caused burns. 1.7 million is the number of unique AI responses that were generated from 1,000 different cases, like emergency room scenarios that were given to these models, and they were given the same symptoms, the same presentations. The only variable in these things was the patient's race, gender, income, or housing status. And that caused it to generate different outcomes. Too fast. The FDA has authorized over 1,200 AI-enabled medical devices. 97% of them came through the 501k pathway, 510k pathway rather, which only requires that a device be substantially equivalent to something else already on the market. Doesn't have to improve outcomes, doesn't have to be tested in clinical trials. 43% of those AI device recalls happen within the first year of authorization. We're deploying AI faster in healthcare than we are building the systems that we need to govern it. So what do we do? I want to talk about three categories of guardrails. I'd like to talk about getting the slide to change first. All right, great. Three categories of guardrails: data guardrails, and we want to go through model guardrails, and last, organizational guardrails. So the data guardrails, sorry, data guardrails really have to do with the data that's trained on. If you train a model on data, that's what the inference is going to be based on. If you don't train it on something, it's not going to be able to produce it. So it's really important to understand, does the data have any bias to it? So like that one example I just gave about the 1.7 million different responses, um, it did it because it was trained on that data. It's not malicious. It's just math. So you have to take a look at the data that you're presenting it. If you're giving it cases that are all from one socioeconomic group, that's what the output's going to do. If somebody doesn't fall in that group, it might do something different. There's a nature of medicine study, um, that nature of medicine study rather that I mentioned. It's a result of training on historical data that already contains decades of potential systemic bias that can cause these outputs to go astray. So input validation is what you do when it's where you check things before they reach the model. You want to make sure that your body parts that are mentioned, organs that are mentioned, are actually real organs and real body parts. You want to make sure that you build bias detection into the pipeline. So if an answer is coming out for two different cases, and the only thing that's wrong is some demographic information, that's a clear bias. You want to be able to catch that with guardrails. By the way, all this is possible today. There's lots of packages out there, in the Python world and other places where you can plug in these guardrails. They can call custom scripts. Claude has hooks now built into the product that allows you to do this. So these are not far-fetched things at all. Also, it's important to understand where the training data comes from. So where did it come from? Who did it pertain to? And then lastly, on the data guardrails is PHI and PII handling. Most of the companies I work with understand HIPAA, right? But a lot fewer have thought about what happens when the data that they feed into a model carries the biases of every single clinician, every insurer, and every system that ever generated it. So this is a very necessary step if you're using a model. You want to make sure you're checking the biases. If you're training additional layers on top of a commercial model or an open source model, you have to do the same thing. The next are model guardrails. I'm not going to wait on the slide. I'm going to keep going. So the lock-in case is a model guardrail failure. So AI generated an output. Nobody checked it. There was no human in the loop trigger that existed to catch this. So model guardrails answer a simple question. When should the system defer to a human? So where we are with AI right now, I think you definitely have to have a human in the loop. And I would even argue in a lot of cases that if you're using it to code, I code all the time still, and I use Claude Code and I check it, right? Just a quick aside, I had 3 clients a month ago, some of my security clients, and 3 of them had data breaches because of AI generated applications, because the people that were guiding the technology didn't know what to tell it to do to generate a secure application. So same thing here, right? You have to have people that understand what's going on, understand these cases and the diagnoses so that the proper decisions can be made. So obviously human in the loop is triggering somebody to manually look at it. Confidence thresholds, all these models have a way of giving you some sort of probability of this answer being correct. Um, if it's too low, you probably shouldn't go with it. Hallucination detection, I mentioned that earlier about the body parts and organs. Um, but there's an encouraging thing about this study is that a simple built-in prompt could have caught a lot of these things. Um, it's not expensive. It's not complex. It just has to exist. It's just a step you have to take. The last ones are organizational guardrails. This is where most healthcare organizations really have pretty low maturity. And there's a lot of real risk that lives here as well, especially on the compliance side. One of the things driving that is shadow AI. So there's people in healthcare organizations that are using their own AI, ChatGPT, Claude, Perplexity, Gemini, whatever it might be, to do things like draft notes, summarize record, look at physicians' notes in an encounter record, and decide whether it's complete enough to go through the claims process. In most cases, nobody's tracking who's using these things. People are just doing it. It's creating a lot of unnecessary risk for the organizations. And I'm not saying this in theory, right? I'm saying this as somebody who builds these things for organizations, both healthcare and other types of organizations. So there was one case where I walked into a situation where they deployed a bunch of AI tools and they were trying to get their arms around it. So I asked them about their AI governance policy. They didn't know what they had, didn't have one. I asked them who was validating the outputs. They had no idea. That meant nobody. I asked whether anybody was tracking which staff was using these tools. The answer was no. So we went in and built a governance program for them. So that included a governance committee, incident response plan, AI tool inventory, lots of other things. And none of this is anything revolutionary. This is just necessary. These things have been done in other compliance frameworks for years, in other businesses for years. And for some reason, this excitement around AI, this stuff is falling by the wayside, and it's going to create a lot of issues. So I do want to leave you with a prediction. This is not mine. It's from Dr. Aaron Neinstein, who's the chief medical officer at Notable Health. And he wrote in December 2025 that 2026 will bring healthcare's first major public outcry moment with AI, a highly visible failure. It's going to be an incident that triggers public fear and demands for a pullback. And I happen to think he's right. And I believe it's going to separate organizations into 2 categories. The first category is organizations that build the governance crisis ahead of time. It's the governance process before the crisis. They'll respond with some transparency around it. They'll put these programs in place. They'll slow their roll a little bit to have these things in place before they implement, you know, full end-to-end AI automation on things. Those are the ones that are going to weather the storm. The others that are doing this later, that where governance of AI is always something that happens after the fact, or they'll get to it later. They're going to struggle. They'll scramble. They're probably going to face lawsuits. So I think it's obvious which one of these companies you want to be. Wow. All right, I'm just going to keep going. That's the last slide. We'll preview. All right. So I'm going to go back to Gene for a while, for a minute. The guy that had to pay $14,000 a month. 9 out of 10 denials are wrong. The company kept using the tool anyway. That's what healthcare without guardrails looks like, and that's what the absence of governance looks like. So the important thing is, and you've already seen the slide, you know what to do. Build your guardrails now, make sure they're in place, and check them for accuracy. Appreciate your time and your patience struggling through this presentation. Happy to take a couple of questions if anybody has any. Yes. I haven't seen that, but
So
great.
yeah,
Thank you.
yeah.
Thank you.
So it has happened.
Yeah. Yeah. This is dangerous territory. Yes, I do. I'm not sure. Well, now that I'm through the presentation, I'll tell you the company was United Healthcare, and their subsidiary, I think it was InHealth, is who built the model. Um, I'm not sure about that, but all I know is that United Healthcare is the one who denied the claim. Yeah. Lots of documentation out there on it if you're interested. All right. Yes. Yeah, I can tell you in general. I can't tell you specifically on that model, but in general, they're getting it from their own, from the medical records that they already have access to. And they're building models based on, here were patients' symptoms and conditions, and here was the outcome, and here's how much care was needed to get that outcome. So in that case, there was some, anomaly or something in the data for Gene where it said you've had enough care, time for you to go. Yeah, 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 right. Right. There's, I can't remember the term off the top of my head, but back in the mid 20 teens when I was building some machine learning models for e-commerce, I think they call them features. Like just, you want to be very picky about the fields that you use because they can influence the outcome. So you want to pick fields that have a high specificity to the output of the model. So I think eventually you're going to see models that aren't just healthcare models. You're going to see very specific models for specific conditions, and we probably need to move that in that direction to get the sort of the confidence score up on those things as well. Great. Well, thank you for your time. Appreciate it.